What's shaking, baby? My name's David Mitchell.
My name is Noah Taylor.
We're going to walk you through a Python script used for ArcMap 10.1. This was a set of Python script designed for Dr. Dan Ames in his Civil Engineering 594R Geoinformatics course at Brigham Young University.
And the purpose of this project is to solve an engineering problem. That problem being that we have a number of earthquake events that have occurred in Utah over the past 5 years, and we want to consolidate those into a single PDF with each PDF representing an event. And to do this, we're going to be accessing the USGS website, and which has a database of all these events. Here, that is right here, and then we're going to be accessing unique codes to each event that are called event IDs. And we're going to consolidate all these into a text file called names.txt to be able to download all those and reference them. Some of the files that we're going to be able to need before we start the script is a template file, as seen right here, that we're going to read into all these event IDs when we run the script. And the rest of the needed files to run the script are going to be zipped up in a file that's going to be associated with this script, and it's going to be called GIS Mitchell. And in this file, as long as you have this file and you have the script, you can be able to run our script. In the case that you don't have the file associated with it, we're going to include all those files needed in this introduction right here.
Alright, so let's jump right here into the code. The first thing that we do is we import a series of modules that will be used throughout the entire Python script. What we do here is we're referencing and opening a text file called name.txt that contains a series of USGS earthquake event IDs and imports them into an array that will be used in the for loop later on throughout the project. The next thing we do is we just set the file path for a PDF file that we'll be creating later on in the code.
So we're going to move right along in the code right here, and we're going to the spot when we're going to start downloading these zipped up files from the USGS website database. And that's pretty much what this code does right here. Is it's looking for each individual event IDs at the same directories on the website. And this is the website that it's going to be referencing. And here is the urlib2, which is going to be helping to open these websites and downloading the files. So these are the paths that we're going to use for the zip names where they're being downloaded. And right here, we're actually unzipping the files. Now, the first time we unzip it, we're actually going to do this twice. The first time we're doing this is for the text. We want to make sure all the data that we need is in that text file. So we're going to actually download it. And right here, we go from .xyz to a .txt. And this is going to be for our benefit, so we make sure we have everything we need. And shortly after that, we're going to re-unzip those same downloaded files, and we're actually going to make the .csv file.
Now this .csv file is kind of a pseudo .csv. We need to do a little bit of tampering with it. The first thing that we need to do is we need to copy that first line and import it into a details file. This is just a details file that contains all the metadata that we'll be referencing later on, like the latitude, longitude, the magnitude, etc. of the earthquake. The next thing is that first line, once we've copied this into a details file, is that details file is we're going to look at the first line of the pseudo CSV and delete it because we don't need it anymore. And that first line is going to be replaced with XYAVI, which correspond to the latitude, longitude, acceleration, velocity, and intensity of the earthquake. And after this, it's a true CSV. Now, for ease in in the Python code, we're going to put all these CSV files in a set folder called CSV files under Python project. You can see here. This is just for ease in the code later on.
Now that we have all our files necessary to make our ArcMap objects, we can go ahead and start with our ArcPy module. As you can see here, we're using ArcPy to open a workspace and also overwrite any previous data so that we can rerun our code without any hindrances. We're reopening also this list of files, these event ID files, so we can be able to use them in ArcMap. So you may notice that we're using a try and accept tool, so that in case there are files that are kind of buggy from the website, that our script will keep going and it won't be hindered. So right here in this first part, we're just double checking and making sure everything's a CSV, and then we print out now processing in the event ID code so we can know which file we're working on. And here we're establishing all our variables that we're going to be using in this for loop, as well as opening or creating a PDF document so that we can save it later. Here we set our spatial reference, and then our files we're actually working in system WGS 1984. Okay, and
Projection.
so yeah, it's a projection. And so we make, from there, once we have all our variables identified, we can use ArcPy, the map XYZ event layer. We can make a layer, afterwards make a shapefile from that layer, and we can take, here we establish another code so we know what event ID we're working on for coming down here. And so after we make this shapefile, we can actually make a raster, and we do that with this try and accept tool right here. We use the IDW option for the raster, the inverse distance weighted, and here where we put our options in for that interpolation option. And if we do run into a problem, we're just going to accept that particular event ID, and we're going to say problem with file, so we know what particular event ID we're having that problem with. Finally, we run this event code so we know we can assign that problem ID with a certain variable. We called it problem for obvious reasons.
And it's just basically so that we're able to pass that and still keep our code running. The next thing we're going to do is we're going to set up the data frame and the map layout so we can add the necessary metadata that we need. The first thing that we do here is we create a raster that we use for the geoprocessing. The next thing we do is we identify the symbology using a symbology layer that we created before, just so we have a uniform symbology throughout the entire atlas. The next thing we're going to do is we're going to tell ArcMap to refresh the active view and refresh the table of contents. This here gets the extent of the data frame and zooms to the area in question. This portion of the code here just basically turns on and off layers that are not being used currently for making the map. The next thing we're going to do is we're going to read the details file and get the necessary metadata that we need to import into the map, such as the US event ID code, the magnitude, the location, and the occurrence of the earthquake. This next bit of code replaces text boxes corresponding to title, magnitude, location, and occurrence with the necessary metadata that we created up here. Then we tell ArcMap to refresh the active view, refresh the table of contents, and we give it some time to kind of take a breather and catch up. Otherwise, ArcMap will crash. The next thing we're going to do is we're going to take that page and export it as a PDF. We just numbered them depending on where they occurred in the name.txt list, 1 through however many were in there. The next thing we're going to do is we're going to save and close the PDF and reset the template back to what it was before so that we can create even more math for the atlas. This here also removes any layers that were created and re-add the base map to the active view. Once again, we give ArcMap time to catch up, save and close the PDF, and this except here, just what Noah was talking about earlier, where in case there is any problem, the code will still keep on running instead of crashing.
So now that we've finished all our ArcMap geoprocessing, we are going to consolidate all those PDFs that were generated from the MXD file. To do that, we make a list right here of all the PDFs, and we use the appendage pages in this little for loop right here to be able to generate one consolidated master PDF, if you will. We save and close the PDF, and from here we print out to the screen program complete, and we say where the PDF, the master PDF, is located on your local drive. We now want to go to ArcMap, and to show you real quick how easy it is to load in our code, our script, and we will start to run it. We won't finish running it just because it's going to take so long, but we're just going to show you how it starts out. There you go. That's that.
Alright, and with the magic of YouTube, the code is now complete and instructs the user of where to find the final PDF atlas, which can be seen here. This is David Mitchell.
This is Noah Taylor.
Signing off and everything. Thank you.